Tony Celzo here. We got an exclusive update on the line. First time ever, we're going to see an in-live demo of a revolutionary technology prototype we've got here, right? It's ugly, but it works. Right here on the line, GETA. I got Atif and Eric, the founders of GETA. This is a revolutionary technology that, mark my words, is going to change the way we consume technology right here in Indiana.
So what you're looking at here is a handheld supercomputer, essentially rendering the Mandelbrot set, which is a very standard demo that's used in high-performance computing applications to benchmark devices. And we're running this on this little box here at about 60 frames a second. That is faster than you can do on your personal computer right now. I'd also like to show you another demo that does real-time ray tracing on this little device. So what it's doing right now is you can see these three spheres that are being rendered on the fly. The computer is calculating the reflection off of every single pixel in that image and using physically based principles, figuring out what the actual color of that pixel should be in black and white as a light source is shining on that scene. This is being done at 60 frames a second here, and this is traditionally done on high-performance GPUs or supercomputers, and we're doing it with a device that's going to be as small as a little Apple TV that'll fit in your hand. Ray tracing basically uses physically based principles of optics to calculate the actual light reflection off of synthetically generated objects. So imagine you're in an augmented reality environment and you have ambient light from the sun or from other environments, environmental lights, and you want to display a three-dimensional object in your field of view. Well, ray tracing can actually compute the physical reflections of that object as if that object was real and present in your environment. And that can be done in real time on this box.
So that was the first one, and that's just showing the pure mathematical prowess of what this thing can do that's sitting on, that you're going to wear, by the way. I mean, and that power used to be only in supercomputing, and now it's going to be actually something that you can wear. The second example was the one that was...
Yeah, so what we were doing is we're computing something called the Mandelbrot set, which is a standard mathematical algorithm that is used to demonstrate the power of parallel computing. And it's used in a lot of supercomputing demos, but we're able to actually demo it here running at 60 frames a second.
And some of the power is that every person that is empowered with this makes the network stronger.
That's correct.
So the opposite of network degradation happens with GETA, meaning that every time someone buys another system, you're sharing that computing processing power with them.
Exactly. You can imagine the box being part of a giant set of nodes of supercomputers. Each one by itself is a supercomputer, but then when you combine them together, you get enormous compute power. And as people buy these boxes, and other people are able to share those computing resources, you can imagine the totality of the network bandwidth and processing power available just gets bigger and bigger with time.
So Atif, just I wanted to close out with one thought here. 1.8 billion people on the internet right now. That number is going to 5 in the next 5 to 7 years. Those people don't have landlines. They're going to be mobile, right? How is this going to change the way what those people are empowered with?
So there are a lot of applications for this right now. For example, we're talking to people in West Africa, a country in West Africa that is interested in incorporating these technologies for distance education for their kids. So a student who's sitting in a classroom here in the United States can share the same instruction with someone who's sitting in Africa. So those kids in Africa now are able to kind of learn in the same way that kids here in the United States are able to learn. And with this type of technology that delivers that experience on the spot using mobile supercomputing and using wireless technologies, we're able to deliver that same experience overseas.
It's really a leapfrog, right? I mean,
Absolutely.
it's not that those kids in Africa can actually have a better educational experience, or at least more access to computing power, to what that can do to change the way they augment and learn and really adopt technology than maybe somebody here in the States, right?
Absolutely.
Yeah, it's the goal is to have the same education.
Right.
A global education connection that all kids across the earth will have the same opportunities as anybody in any country.
And mind you, that's just one. That's one application. I mean, there's fun applications like, augmented reality, like what that could do and allow us to. There's research, putting this in the hands of docs, being able to break down and learn about molecules in ways that accelerate drugs to market at a rate of 10x or 12x, right?
Right.
This is really something that is going to change the way we consume technology.
Right. One of the nice things is that this box currently runs Android. So if you have Android applications that you have at home that you're using, you can run them out of the box on this device without modification. And that's very powerful because we can now embed this kind of device into many, many different environments where quick apps, apps that kind of load quickly and execute quickly are necessary. And this is able to deliver that type of technology.
And the power of that, of when you're not using that, and having that access go to somebody else. The fact that
Right.
that node network gets bigger and bigger the more that are sold.
Exactly.
This thing can be working on answers to problems that it's accumulating in the now, almost becoming a virtual subconscious that goes to work on some of those things to really, really drive down and define and figure out some
Exactly.
huge breakthroughs based on the user. Because this could actually learn the user more and more.
Exactly.
Where we're learning to adopt technology, this thing could adopt us.
Yes.
Exactly.
And that's really the way we see mobility changing, the way we see supercomputing or in the mobility environment. What'd you call it?
Absolutely.
You call it something better than I just did.
We call it the mobile cloud. Basically, we're taking the cloud and we're democratizing it and putting it in the hands of people like you and I. And we have many examples of where that's useful. We have a company we're working with in California that's developed an augmented reality helmet. And we find that the processing power in the helmet is being consumed entirely by the augmented reality experience. So when you have workers in oil fields and in industrial environments that need to use more powerful computing, cloud computing, to be able to analyze the data they're gathering, they have to send that data to the cloud using Wi-Fi connections. And in a lot of places, those Wi-Fi connections just aren't available. So having the ability to do that computation on the spot is extremely helpful.
Yeah.
And it changes the game for them.
Yeah. Right here on the line. Thanks, guys. It's great being on the
Thanks,
update.
Tony.